Hi everyone, we are continuing on properties of similar triangles, and to start off we're going to talk about geometric mean. So first, a definition. The geometric mean is given positive numbers a and b, a positive number x such that a is to x as x is to b. Or if we solve this out, where x squared equals ab. Alright, so we're generally going to want to use this form. Makes everything super simple. So for instance, in example 1, it says find the geometric mean of 4 and 25. So we could set up our proportion. 4 is to x as x is to 25. But what this is really asking is x squared equals 100, solve for x. Okay, so solve for x, we get 10. Same thing here. So find the geometric mean of 3 and 8. So all you would need to do is set up x squared equals 3 times 8, which is 24. And solving, x would be the square root of 24. We could simplify this to 2 root 6 if you want. Okay, moving on, we have the geometric mean, 12 is the geometric mean of 8 and what number? Alright, so let's set this up. That means 8 is to 12 as 12 is to some number. Right? That's what we're trying to find. So solving this, we get 8x equals 144. So x must be 18. Okay, and then last one, what is the geometric mean of root 28 and root 7? So we're going to multiply these together. So root 28 times the square root of 7, that is the square root of 196, which, if you have your perfect squares memorized, this is 14. So x would be the square root of 14. Alright, so moving on down, we have just a little corollary about similar triangles, where we say that corresponding angles in similar triangles are congruent, corresponding sides are proportional. Right, and that's really the main idea behind similar triangles as a whole. So let's talk about our next theorem. Okay, so our theorem states that if we have a right triangle, okay, the altitude to the hypotenuse of a right triangle forms two triangles that are similar to each other and to the original triangle. Okay, so what we mean by that is if we draw the altitude of our original triangle here, ABC, to the hypotenuse, okay, we end up forming two triangles, ABD and BDC. Right, so this is DBC and this is ABD, right? Where our right angle is here at D. Let's draw it a little better. And then here, for our original triangle, our right angle was at B. But we divided B into two angles here. And what we're saying is that this triangle here is similar to my triangle here, which is similar to my triangle here. All right. That's our theorem. Now a few corollaries here from this theorem about side length. So what we're going to say is that the length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the two segments of the hypotenuse. So now we're going to combine kind of the two ideas we just talked about. Okay, so what we mean by that is given our triangle ABC here, where C is the total length of my hypotenuse and H is my altitude, what we can say is that D is to H, okay, so we're taking just our segment here, D is to H as H is to E. Okay, so our altitude kind of corresponds with the two segments of that make up my hypotenuse. Okay, now we're going to use both of these triangles here. What we're going to say is that the length of a leg of a right triangle is the geometric mean of the length of the hypotenuse and the segment of the hypotenuse adjacent to that leg. Right, so what I mean by that is essentially we can, this goes for both legs, if you will. Let's use some colors here. So let's talk about A first. Okay, so if we consider leg A, okay, and we're comparing this, or we're using our hypotenuse, but then we're also just going to be using the segment that's adjacent to that hypotenuse. Sorry, the segment adjacent to that leg, which is just D here. Okay, we can create a relationship. So what I know is that C relates to A as A relates to D. Right. So we're using the hypotenuse, the section of the hypotenuse adjacent to my leg, and then the leg. Okay, and then obviously this would work for the other leg as well. So if we used B instead of A, okay, then this time we would use segment E, and we would still use the entire length of the hypotenuse, C. Right. So if we set up our proportion, it'll look very similar. So C is to B as B is to, this time, E. All right. So that's the idea here. All right, let's move on. All right, so let's use this in a few examples. So first example, they want us to find x, which is our altitude. So we just need to set up our proportion using our corollaries that we just learned about. So I have my segments here, 18 and 8, which make up my hypotenuse. So that means 18 is to x as x is to 8. All right, so solving for this, we're just finding geometric mean essentially. So x squared is going to be 144, so x is 12. All right. Now, similar thing here, except this time I'm going to be using the leg instead of the altitude. So what I know is that the entire hypotenuse is a length of 20. Yeah, I need that. And I'm going to relate the hypotenuse. So 20 is to my leg, x, as x is to the adjacent segment of the hypotenuse, which is 15. Okay, that means x squared is going to be 300. So x is going to be the square root of 300, which we could reduce to 10 root 3. Alright, I want you to go ahead and give this one a shot, so pause the video now and try this, and then see if you got what I got. Alright, so we're going to approach this the exact same way that we approached example 4. So first I have a hypotenuse length of 12. So setting up, I know that 12 is to my leg x, as x is to the segment adjacent to my leg, so 3. So x squared is 36, x is going to be 6. Alright, next few examples here. So this time they give us a triangle and they want us to find 3 variables. Okay, so the first thing that we really need is, considering I have 2 legs here, I need to know the length of the hypotenuse. Okay, so in order to do that, I need to find x first. So let's solve for x. I can set up my using the altitude and then my 9 here, so the other segment of the hypotenuse. I can solve for x, so x will be to 6, sorry, as 6 is to 9, right? So we're relating to our altitude this time. So that means 9x is going to be 36, x is going to be 4. So that means that my hypotenuse has a length of 13. Alright, now I can solve for y and z, and it doesn't really matter which one you solve for first. So let's solve for y. I know that 13 is to, let's put it up by y here. So I know that 13 is to y as y is to my adjacent, which is 4. So that means y squared is 52, so y is the square root of 52. Okay, now z. Solving for z, I know that 13 is to z as z is to my adjacent, which is 9. So multiplying those together, I get z squared being 117. So z is going to be the square root of 117, which you could obviously split that up into 9 and 13. So 3 root 13 if you wanted to. Alright, last two problems here. We have the altitude of a right triangle, dividing the hypotenuse into segments that are 8 and 10, and then find the length of the altitude. So I know that I'm using the very first corollary. So I know that 8 is to x as x is to 10, where x is my altitude. Right, so multiplying these together, I get x squared equals 80. X is going to be the square root of 80. Which you could reduce to, you take 16 out of that, so that's 4 root 5. Okay, and then last problem. So this is a slightly more realistic scenario of how one might estimate the height of something. So in this case, we have a height of 1.6 meters, and we're trying to estimate the height of this tree. Okay. So we know that we're forming a right angle with our eye line. The eyes are 1.6 meters above the ground, and we're standing 7.8 meters away from the tree. Right, so we want to know the height of the tree, so we're solving for this right here, the hypotenuse. So it would be easiest if we assign some variables. So let's assign variable x, let's say here. And I know that I can use, again, the same corollary we just used. Since I have the altitude and I have a segment, I need the other segment. So I know that 1.6 is to 7.8, which is my altitude, as 7.8 is to x. Right, so solving this out, we get 1.6x equals 7.8 squared. We can plug this into our calculator and solve. I would get that x is 38.03. Alright, so that is just this segment, this upper segment of my hypotenuse. Now I need to add 1.6 to that. Let's do a better 3. 38.03 plus 1.6, so that will give me 39.63, so about 40 meters. It asked to give me to the nearest meter, so I would say 40 meters. Alright, that is it for these notes. Your worksheet is in Classroom, and let me know if you have any questions. Otherwise, have a fantastic rest of your day.